Hi, I'm Milan Gandhi. We've developed a fuel efficiency analysis tool. This is the exe file executable. We'll open it. It will take a couple of seconds to activate. So this is the tool, fuel efficiency analysis tool, which consists of two applications: LLC versus NLC analysis and fuel airfare analysis. Both these applications would have the fuel, will be having analysis of the fuel. First application is the LLC versus NLC analysis. LLC means it's low cost carriers, and the NLC is the network legacy carriers. So we'll see the difference first. Network legacy carriers, they are more traditional airlines, operate large hub and spoke networks, regional, domestic and international services they provide. Examples for this would be United Airlines, American Airlines. They have larger aircrafts, they travel longer distances, that is the average stage length. Higher spend on passenger service per RPM. RPM means revenue per mile. For the passengers, they spend much more than the low cost carriers. Higher spend on traffic services per enplanement. Whenever a passenger goes through the formalities of enplaning a particular aircraft, so the service charges required, they spend more. Higher maintenance cost being larger aircrafts for the per block hours of the aircraft. Higher promotion and sales cost. Now LCC is the low cost carriers which operate smaller networks, high proportion of point to point or non-hub operations, reduced levels of services and low fares. Examples for the low cost carrier is JetBlue, Sprite Airlines, Southwest Airlines. Freight commodity, it reduces the cost of spare parts, maintenance and crew training. Point to point, instead of connecting the hub network, it reduces the cost of handling connecting passengers and improves the productivity of both the aircraft and the crews. It's a single cabin class service. It reduces the complexity and the cost. Open seating, less time of processing the passengers. Reduced frills, no food, no beverage. Increases the ASM, that is available seat miles, and reduces the passenger service cost. Now this is the first application we have just distinguished, and then the second application will come when we complete this first application. So let's start with this application. This is predefined input data. What I'll do is I'll click on new row, and all the data will, what we want to we are using for this particular demo will be generated. This is done on the developers mode, means when the developers are developing an application and testing it, so they just input this data, so they need not put it all time again and again, and they keep on testing it until they get it correct. So when I click on the new row, the data will be generated, and once the data is generated, we will click on the generate button, where we will save this generated data, that the output including the input, in a particular Excel file, and then we'll analyze and we'll look into it what exactly this application is all about. So I'm clicking on the new row. Okay, so this particular aircraft type is there, and these are the years. We are comparing two airlines for the fuel analysis. We have taken the data from excuse me, we've taken the data from for 2005 and 2008 for two airlines, JetBlue Airways and United Airlines. with the aircraft number, aircraft type number, aircraft number 694, and we have input all these particular parameters. This is the user will be inputting for this particular application, and we'll just click on the generate button, and so we can see all this data including the output which is supposed to be generated. So here we go, we just click generate. We will save this file from where we have started our application, and name this as LCC space NLC. That's the name of the application, and we'll comparing both this particular different carriers. So we'll see the application here. It must have generated the report. Yeah, it is generated. It's an Excel file. We'll open it. So we'll analyze both the types of carriers, the low cost carrier and the network legacy carriers. So this is the file generated. The yellow highlighted is the data which has been input here. This is what the data which has been input here. So, and the output is the one with this particular, the calculated part is the output generated is in white. So this is the input. First we'll look at the input, what it is. First we'll look at the columns. This is the year 2005 for Jet Airways, JetBlue Airways and United Airlines, and this is year 2000 data for JetBlue Airways and United Airlines. This is the sum of the crew. Sum of the crew is the cost of pilot wages and the benefits to them. And then the second column is the sum of fuel. The fuel is basically a variable cost, the amount being spent here. Then this is the maintenance of the aircraft, sum of the maintenance. These are the amounts out here. And the ownership, that is the ownership of the aircraft cost is here. So sum of the maintenance cost, what would it be? It would be a direct airframe and engine maintenance cost plus burden or overhead, that is hangars or spare part inventory cost. Ownership cost consists of the depreciation, leasing cost and insurance, and that are the figures out here. We are talking about a year for 2005 and 2008. The respective data is here. Then the sum of the fuels issued when this aircraft 694 was flying. So in a year, how much the fuel was issued to this aircraft for both these airlines. So this was the numbers for that, and then the sum of the total hours flown by this particular aircraft in this particular year 2005 and 2008. So this is the figure for that. So we'll just look at individually now. This is 1 million sum of crew cost was for Jet Airways, JetBlue Airways was 1 million, the approximate 1 million, and the rest of hundreds, thousands. And then some fuel cost was 4 million. Then the maintenance cost was 809,000. Then the ownership cost was 9 million, and issued fuel which was issued was 3 million, and the sum of the total air hours, this 330.5 hours it was flown for year 2005 for this aircraft 694, for JetBlue Airways. Now we look at United Airlines. It had crew cost was approximately 1 million. The fuel cost was 6 million. The maintenance cost was 2 million, approximately, more than all that. Then the ownership cost was 14 million for that year. Then the issued fuel was 3 million, and the number of hours flown for this particular aircraft 694 for United Airlines was 332 hours for that year 2005. Now let's look at this particular JetBlue Airways for the year 2008. Now it was 1 million for the crew cost, approximately, more than all that. I'm just giving a round figure, approximation figure, 1 million, and whatever the thousands added to that. And the fuel was consumed was the cost was 11 million, and then maintenance cost was 1 million. Then the ownership cost was 17 million, and the fuel issued was around 3 million, and the number of hours flown for this aircraft type 694 was for that year 2008 is 424.55 hours flown. So we look at the United Airlines for 2008. For the, it was 1 million for the crew cost, 10 million for the fuel cost, that is 3 million for the maintenance cost. Ownership cost was 22 million, and sum of air fuel issued was 3 million, and the number of hours flown was 371.62 hours were flown for aircraft 694 for United Airlines in the year 2008. Now we are comparing. JetBlue Airways is a low-cost carrier, and the United Airlines is the network legacy carrier. As we saw, what difference between the low-cost carrier and the United Airlines. I mean to say the legacy network legacy carriers. So the output which is generated here, which is in white, is the now this particular figures are hourly figures per hour. It is the calculation. What is internally done is, here we've seen the number of hours which were flown by this particular aircraft 694 for JetBlue Airways was this much. 330 hours were flown in that particular year of 2005. So what is per hour cost for this particular crew cost? It comes to 3051.6 is the crew cost per hour. The same way for fuel cost was $14,000 per hour. The maintenance cost per hour was 2,449.1. Then for ownership cost for per hour 28,000. Then sum of the air fuel issued was $9,000 approximately, and this is just a nullified value. It's dividing the same to same, so this is not to be considered. United Airlines for year 2005, using this aircraft 694, based on the data given here on the number of hours flown, we are just coming up with a calculation of per hour. It costs the crew cost was around about $3,968.3 per hour. Then for cost of the fuel was 20,000 approximately, and then the maintenance cost was 7,000 per hour. Then the ownership cost was $43,000 dollars per hour, and then we have $11,000 of air fuel issued, and then this is for the year 2005 per hour calculations. Now we look at 2008. We can just see the JetBlue using this particular aircraft in 2008. What was based on this particular figures 2008 year with the number of hours flown. So it per hour it cost $765.1. That's a crew cost per hour. Similarly, fuel cost was $26,000 approximately. Maintenance cost was 3,000 approximately. The ownership cost was 42,000 approximately per hour, and 8,000 was the air fuel issued per hour. 8,896.3. So that was a JetBlue for the year 2008 for the aircraft flown 694 for with the number of total number of hours flown, and we are getting per hour calculations. The same with United Airlines. It cost $3,807.9. The cost of crew per hour. Based on this, we are calculating 2008, and these are the figures on that. We've got this particular figures. So here we were, and so here fuel consumption fuel cost was $28,800.5 per hour, and we have the maintenance cost of $8,617.7 per hour, and then ownership cost was $59,000 per hour, and the air fuel issued was $10,000. Now looking at these figures, this is the hourly breakups. What we did the hourly cost which were incurred by both these airlines, the JetBlue, that is the low cost carrier, and the United Airline, that's a network legacy carriers. So what was the difference? We can see here is the difference. So it helps in analyzing an airline, how to come up with a strategy, operational strategy to to finalize the cost structures for that particular aircraft. So we see this JetBlue Airways 3,000 so and so was the for 2005, and for 2008 was 3,765.1. that is a crew cost. So when we compare both this, we get the difference. So there is an increase of 23% for the crew cost for JetBlue Airways from 2005 to 2008. So the difference is 23% of increase in the crew cost for JetBlue Airways. Now we look at the difference of let's see what's the difference for the United Airlines, which was 396 in the 2005, and in 2008 is 3,817. So the difference is -4. -4 means the cost has been reduced from 2005 to 2008. This is basically their strategic input, which resulted in the cost reduction. So here the United Airlines fared well compared to the JetBlue, which had a 23% increase, and United Airlines had a decrease of 4% in the cost. Now similarly, we look at the fuel cost for JetBlue Airways for year 2005 and 2008. 81% increase in the fuel cost. They need to come up with a strategy to reduce this cost. 81% increase, whereas the United Airlines had this figures in 2005 and this figures in 2008, and their increase was 41%. Here also United Airlines have did well to basically increases there, but not to the level of JetBlue. So somewhere down the line, the strategies used by United Airlines had worked for the consumption of the cost of the fuel. Now similarly, we'll have the maintenance cost. Look at the maintenance cost of JetBlue Airways for 2005 and 2008. These are the figures. An increase of 26% of the maintenance cost, and whereas the United Airlines having 2005 this figures and 2008 this figures, the increase is 17%. This would depend basically on the aircraft type which is being maintained. The larger the aircraft, the narrow body aircrafts, and the kind of fleet the airlines has the composition of. Then you will have the ownership. Have a comparison of ownership. Ownership is done by leasing also, or the airline can have their own aircraft also. So a lot of factors to be considered here, with the factors of depreciation also. So the ownership cost here is for JetBlue 2005 and 2008 is here. There is an increase of 48% in the ownership cost, whereas United Airlines has these figures for 2005 and 2008. The increase is 38%, almost 10% less than the JetBlue. Then we'll have some of the air fuels issued. This for JetBlue Airways 2005 and 2008 is -3%. Okay, there was a decrease in the cost of the fuel issued. So fuel issued was 913 and here it is 889. So the difference is it's a decrease in the cost. So $9,135.5 per hour, whereas that was in 2005, and in 2008 it was $8,896.3 per hour. So there was a reduction in this cost by 3%. So this is somewhere the strategy has worked in reducing the cost of the fuel issued for this particular aircraft for this particular year. So it was -3, so reduced cost. And the United Airlines issued the fuel issued was $11,885.7 per hour in 2005, whereas in 2008 it was 10,000 uh, 10,035.5 dollars per hour. So there was a decrease, minus 16. There was a decrease of the amount spent for the fuel issue to 16%. So United Airlines did exceptionally well in the year 2008 to reduce its fuel cost, the fuel which was issued for this particular aircraft to this particular level of decrease to 16%. So the strategy from the United Airlines was much more successful, and fuel cost is basically also variable. It's a variable cost, and fuel hedging also takes place. So it depends from airline to airline to come up with the strategies for the reduced fuel cost. And it basically all this factors, all this cost, crew cost, fuel cost, and maintenance cost, ownership cost, and they all constitute almost 50% of the operating cost. These are the flight direct operating cost. The flight operating cost is called, which constitutes the major for a flying operations. Basically, it will constitute a major cost for an airline to consider. So this needs to be considered from the strategic point of view for any airline, for the cost restructuring, cost minimization, and other ways to strategic look at the way they can be the airline can benefit the most. So this is application which has been developed, which would airline could compare their previous year's data and then come with a strategy that would be beneficial for them to reduce the cost. And now this is the first application, and now we'll go for the second application. This is the fuel airfare analysis. What this application does, I'll just close this. What this application fuel airfare analysis does is, there are different parameters in this. Basically the airfare part of it. It would answer the questions like which airfare. There would be number of airfares. So which airfare generates the maximum total revenue? Which airfare generates the maximum profit, and how many passengers are transported at this value? We'll just have a look to understand this. This would be the basically the input fields here. So this would be we're concentrating here on the average airfare which would be offered to the passengers. So how much profit is gained when an economic operating point is shifted from the maximum revenue point to the maximum profit point, and how many passengers are no longer transported. So here we have all this particular columns considered for the revenue and cost, and based on that we'll get the profitability, revenues, and the cost. So it would answer this sort of questions. If the airfare is decreased from the maximum profit point, how much profit is gained or lost, and how many fewer passengers are transported? Then if the airfare is increased from the maximum profit point, how much profit is gained, lost, and how many fewer passengers are transported? So these are the questions which will be answered, along with a question related to the fuel. Assuming that airline operates at the maximum profit, what is the impact of the increase in fuel prices from 1 gallon to 3 gallon, from $1 per gallon to $3 per gallon, on more or less passengers would be served, or whether the passengers would be more passengers or less passengers would be served. what is the impact of the increase in the fuel prices from $1 per gallon to $3 per gallon on an airline profitability. Basically everything what is being done is for the airline profitability. Now there needs the conditions under the conditions for the travel demand, revenue and the cost used in this example, the most substantial approach is to increase the efficiency of the demand for travel increase. That is most passenger, most aircraft, airline profit. The way to improve is by improving aircraft cost performance. That's a non-fuel cost and the fuel burn rate. So this is the way this application has been developed. We'll first look at the same way. This is in the developers mode. So we just click on the new row. All the data will be put, and then we'll generate a report and do the final analysis. What exactly this output says. So we'll click here. So this is the data input. So these are the columns, market, that is from to and fro the flight is taking, and then the market coefficient and so on and so forth, all the columns, and the rates, and then the output will be generated. We click on the generate button. We save this the same place where we saved the previous file, and name this as a fuel airfare. It would be in an Excel file. You just click here. You just see it's come. Yeah, it's already come. So we'll just open this. See what the report is. So this is the report being generated. What it does is, this application does is, the input value has been these are the yellow highlighted fields are the input what we saw here, which was automatically generated because we have kept it in the developers mode. This is the input, right? And this input is being generated, and this are the parameters. We are taking a market from JFK to ATL. That's from flying this particular aircraft is flying from this origin to destination. Now market size coefficient is a sort of a estimation taken by an airline. So here is that particular figures 500, and then airfare elasticity coefficient is there. Okay, so that is minus 0.005 for all this particular examples we have taken, and the average airfare is here. The average airfare is been put is this average fare for this particular route is $100. We have taken $500, 100, 150, up to $450, $500. So we are experimenting with the different airfares, and the number of block hours is the flight time from takeoff to landing is the same. We are taking the same route from JFK to ATL. So, and what would be the non-fuel cost rate? Just exclude the fuel cost, and what would be the direct operating cost for the particular hour. This is per hour. Fuel rate per hour per seat is $12, and fuel burn rate is $9 per hour, and the fuel price, this is where the other change is there. As we change the airfares from 100 and 500, 150 to 450 and 500. Here there is a change in the fuel price for this particular, both the examples is $1 per that is $1 per gallon per hour, and this is also $1 per gallon. If we change this particular fuel price from $1 to $3, the calculation changes with the average fare also. And the rest of the examples we have used the $3. So there is a change in the fuel price as well as a change in the airfare, and the block hours are constant. The flying operations always these are the number of hours the flight would be in flight would be in air. This is this cost is also constant. That's the direct operating cost, and the fuel burn rate would be the same for constant, and there will be a change in the fuel price as well as the average price. And there is a this is also constant. The market size for this, we are taking this route, it's constant 500. Airfare elasticity is also constant. Now the generated output is this: the cumulative passenger demand, total revenue, total cost, and total profit. Now the cumulative passenger demand is calculated by a formula set by this. This is the formula used for market size coefficient into e raised to average airfare and the airfare elasticity coefficient. So we get what is this particular cumulative passenger demand. So for the airfare of so and so $100 for is with a fuel price of 1, with all these cost structures, we are having 303 passengers demand, cumulative passenger demand. What is the revenue generated is $303,265.3 dollars. The revenue is generated. Revenue is the number of seats into the airfare. So we get the revenue, and then the cost is calculated. The cost is calculated via the formula of the number of block hours, what we saw. This is the block hours, number of block hours, and the number of seats. The seats is the cumulative demand. We see, we just saw 303. For this example, it was 303, and then we've got non-fuel cost rate, that is $12 per hour per seat. Then the fuel burn rate is $9 per hour. That's a fuel burn rate per hour, and then we've got the fuel price of 1. And it would be, the calculations will be a little bit changed for the cost for $3 when the price of the fuel price is changed to $3. So we will get the different cost for this particular example. So here also $100 airfare is there. Here also $100 airfare is there, but the fuel cost is changed from $1 to $3 per gallon per hour. So the cost would be different here. You can see this is 318,428.6, and the other one is here we say just $3 change, this $3 per gallon change. So we got 591,367.4. So this makes the difference. So this is the way the whole calculation is done. Now we like to see which particular airfare gives the airline the maximum profitability. So the highlighted cell here is the green one, which says it gives the airline the maximum profitability with the average price, airfare price, and the fuel price, and the cost, all cost associated. So the figure is $162,117.9 is the profitability for the airline, and the rest of the cost structures and airfares has this figure. This is in negative 288 in bracket is a negative, 106,000 is in negative. This is 134,000, and this is 125,000, and the one here is 15,000, and so on. So this combination of the airfare and fuel and the other cost structures gives the airline the maximum profit for this particular route. And so airline can airline would adapt this particular airfare, and with this particular fuel pricing, and this is the way this particular application calculates the profitability, airline profitability. And you can experiment with the different airfares here. We just experimented with 100 and 500 for the fuel price of 1 and 1, the rest being constant. Then we have experimented with the 100, 150, 450 and 500 with the different with the fuel price change with $3 per gallon, and with the rest of them being constant, other cost structures. But ultimately, if this particular, the green highlighted works, it will give them the maximum profit. So this is the way how the fuel increase, the fuel price increase affects the profitability of the airline with airfare changes of the airfare which is suggested by the airlines. The changes here also you can see, and the rest of the parameters remain the same, and they can check which airfare to suggest to the passengers, and at the same time check their own profitability. So this is the application developed for connecting fuel and the airfare and the other factors to be considered. So this is the tool we have developed. This could be a handy tool for the airline to analyze the fuel and come up with a strategy that would benefit the airline for their profitability. Thanks for watching it.